Great. You know, now that I'm finally starting to get some work done on this, I'm also starting to see how much work it's ending up being. I don't think I want to do much more than just being able to put together a basic scene properly. But man, some of this projection stuff is like fairly complicated. Fairly complicated to visualize clearly, I should say. Yeah. Like here, for instance. At some point, I should probably go through the OpenGL pipeline. I think here would be a good part. No, probably the first thing. I can go through the pipeline and then go through how the data is passed with attributes and uniforms, then homogeneous coordinates. I think that makes sense. Then I can go over the basics of OpenGL, basic fragment shader stuff. And that's when I can get into projection, the various matrices. As for rendering geometries, etc., we will get to that when we come to it. And even lighting. Lighting isn't... I don't think lighting will be that in-depth. I think it'll be fairly simple stuff. I'll just have to go over normal matrices. So I will have to do that. And here I'll go over like geometries and materials. Yeah. Go geometries and materials. Yeah, and then just like a really basic example or something. Then I could do lighting and yeah. Yeah, okay. That's gonna be fun. But for now, I need to find a visualization to visualize the projection matrix. I think the first thing I need to do is probably make it so that you can add meshes to other meshes, because I haven't implemented that right now. Aquabeam, what's going on? I'm actually, speaking of the tutorial, I get the feeling that for people who watch my stream, they probably, there's a decent chance they won't need the tutorial if they watch me putting it together. But maybe that's not so bad a problem. Okay, so I made it so that you add and remove things to Object 3D, which is the parent class of Mesh. I think I'm going to bring that down into Mesh. I think I might still need it. The code is a little hard to parse if not fully paying attention. Gotcha, that's fair. So then I'm going to bring down the children array down here. And the parent. Wait, okay. I don't know if what I did just made sense. Because I... Oh, and also I sent you a Discord DM asking you if you wanted to be a community dev. Since reviews are getting pretty backed up, and we kind of need need as many people as we can get, so I did that. Okay, so it's possible to add to Object 3Ds, which means it'll already be possible to add to meshes, which is what I want. I think the only thing, hold on. I'm going to create a cube or something. So I'm gonna say example cube. This should be like get geometry. Wait, mesh. And let me get a box. Oh, okay, because I was being slow. Then I'll get to that right after this. Okay, so I'm gonna get the box and a material. If I just add this cube, it will crash, so that's nice. Geometry doesn't attribute shader program. So that means object.get meshes was returning a shade. Wait, mesh.shader.shader program. So mesh.shader was returning. Oh, I see what I did here. I have to do geometry equals this. Material equals this. I think that's the problem. Close that. Try again. Great. So add in cube. I see the cube here. What I want to be able to do is add this cube to another mesh. So if I do, okay, first of all, I should move it. So example cube, model matrix. Speaking of which, this is a really annoying way to translate things. Multiplying by a model matrix. It'll probably be worth writing a utility function or something, because man, it's just so verbose. Okay. So let's translate it in the X, Y, and Z direction, which is great. I want to be able to add this example cube to a mesh. So if I did mesh.add, now it doesn't appear, and I want to fix that. I think this is in a few places. So here, when I'm scanning the object to get the meshes out of it, if it's a mesh, I just yield it, and I don't extend with its children. And I think I want to extend with its children either way. So if I make that change, it's in a different place, which is kind of weird. Like, why is it? Oh, wait. Does this make sense? Okay, here's what I'm gonna do. I'm not going to modify its matrix at all. So now, I think that cube is inside the circle. I think this actually does make sense. I think. Maybe. So Manim space, which is a coordinate space, which this circle was added to, has been scaled down by the 0.7 factor. And since this cube is a child of that space, I think all of these are also scaled down. Although it seems like it isn't moving in the Y direction. Oh, I mean in the X direction. So if I comment that. Oh, interesting. Y, Z. Oh, mesh 1 is the square. Mesh 1 is this one. So this makes sense. Should have given it better names. Yeah, so now I can see relative to this square, it moved in the x direction, y direction, and up the z direction. So this makes sense. And it wasn't so hard to do. So that's nice. Now what I wanted to do is add this container and the objects within the container into the same coordinate space. So let me do Manim coordinate space goes in object 3D that contains the Manim space and the container. I'm going to self.add that. And if I can get away with not having to add these, nice. That's really good, because that means that I can visualize the projection matrix, should be able to, by simply taking the Manim coordinate space model matrix and multiplying by OpenGL dot. I'll have to write out my own array, actually. It'll be this times the model matrix. Let me make this the identity at first. Yeah. So 1, 1, 1. Now if I add this in, exact same thing. And I want to transform this into a 1 by 1 by 1 cube, since that's what the projection matrix is supposed to do. Let me just take this out and I'll call this projection matrix. Projection matrix equals this. Now replace this here. Perfect. And I'm going to want to shrink this into a 1 by 1 by 1 cube. Now, part of the problem is that in this diagram you can't see where 1 by 1 by 1 is. But I don't care. I'm just going to do it. So let me take a look at the theory for this. So basically, you divide the x-coordinate by the length, multiply by 1. Divide the y-coordinate by the height, multiply by 1. There's the same thing with the z-coordinate. This is just taking care of translations. So I think all I need to do... let me factor out these variables. So this should be... Let me go to the definition of this. Width, height, depth. So... width is this. Height. Here. Depth. There. I call this Manim. Is there a visual? I'm gonna try to take a shortcut here. It didn't work. That time it kind of worked. width, then height. Okay. Okay, so this should do the same thing. Great. So now, how do I squeeze the width into a 1 by 1 by 1? And here I'd have to do 1 divided by that width. And I should see this shrink. Perfect. Looks kind of funny, but I guess that's the point. Oh wait, no, this should be a 2. This should be a 2. Yeah. Because R and T is half of the width and the height. So that should be a 2. It should be a 2 divided by the height. It should be a 2 divided by the depth. Great, so I've mapped the original space into a 2 by 2 by 2 cube. Although it doesn't look 2 by 2 by 2. Why would that happen? Manim space scale. It's kind of weird. Manim coordinate space. That's why multiplied by this projection matrix. Height, width, and depth. I guess I'll have to look into more why this doesn't look like a cube exactly. I wonder if there's a way to print out the depth or the height, width, or depth of these. Width, the x coordinate, height, and the y coordinate. Let me try changing this back to a 1. I'll see if any of these are mixed up. Yeah, this seems to be squeezing the wrong coordinate. Oh, no, it's not. The depth is... the z-axis is going up. Oh, I think these might be mixed up. Should be width. Height is in the z direction, so I think it's like height, depth. There we go. Now it's a cube. So here I did width by height by depth. But here it's width by depth by height. That's kind of weird. Width, height, depth. Maybe I should... because the z-axis in this space is different from the z-axis in the global space. Maybe I shouldn't try to change that. Okay, I don't think that's worth trying to solve now. I will come to that in the future. But anyway, I managed to map this down. However, I want that to like happen continually. I want a visualization of it. So I think I have to clone the coordinate space, which sounds pretty annoying to do actually. Let's look here. There's an object 3D and a mesh. How difficult would it be to clone this? Basically cloning the geometry, the materials, and the indices. I guess that wouldn't be super difficult. But kind of annoying. That's for sure. But gotta do it, I guess. Okay, so here's what I'm gonna do. I have the Manim coordinate space here. I'm going to... here. So I'm gonna try to copy it. I'm just gonna do something like that. And that crashed it already. Well, that's okay, because I haven't implemented it here. And what I'm gonna want to do is I'm going to reproduce the hierarchy of all of these. Would that be that difficult? Yeah, it probably will be. But let me do this. I'm just doing a depth-first search traversal of the children. Starting with self. And when it encounters a mesh, it's just yielding it. When it encounters children, it's just pushing those back on the stack. So I'm gonna have to do something like copy equals object 3D. And then go through and copy these one by one. Wait, this should be, yeah, object 3D. And then what should happen when we arrive at a node? Don't know if it's a mesh or not. If that's a mesh, then what? I'd have to find the copy of its parent. So I'd want to clone it. I'd say copy or like clone. Parent copy equals parent copy. They'll have to add this to the copy of the parent, which should already exist. But I'll actually have to do this in either way, wouldn't I? Whether it's a mesh or not. So in that case, can I just pop this off, copy it, pop this off, extend this children, copy it, and then here I have to add the copy to the copy of the parent. And there's a question of how do you get the copy of the parent? And how would I do that? I feel like I'm doing a whiteboard interview in real time. Well, maybe I should write this out. Let's see if I can get this to work. The live audience pressure, yeah, it's building. It's mounting up. So these objects look basically like this. Have a few children. It's not necessarily two, etc. like this. And when I'm traversing this and I arrive at a node, the parent should have already been copied somewhere. So I'm traversing in depth first order, for example. So I'm going like down this way, then here, down this way, etc. Then after one is copied, how do I create a link from a node to its copy, basically? I think that's not so hard, actually. If all I need is a way to go from a node to its copy, I can use a hash map. So let me try that. So here's a copy. Node to copy. I think you're supposed to do dictionaries like this. A parent. Okay, add the copy to the copy of the parent. And the way I can do that is by saying, parent node to copy indexed at parent dot parent. So this is the copy of the parent. Dot add parent copy. There's way too many parents in this statement. Let me call this node. So node, that's what I'm popping off the stack. I'm extending with its children. Copying that node. Then I'm making a memo. I can go from this node to its copy. Node copy. Oh, this should be node copy. Node equals this. Extend with the children. Copy it. The mapping from the node to copy at this node is its copy. Then node to copy at the node's parent. So this is from the original tree. And then I look it up in this. This is from the copied tree. And I add the node copy. Great. So to start this, I think I need self. And then do I just put object 3D here? Because I would extend with its children. Then eventually when I pop those children off, I'll add those children to this object 3D. So I think that's fine. I will have to copy the normal matrix and the model matrix though. It's actually worrying me that I never copied the normal matrix or the model matrix over. Should I do that here? I should probably do it here. And I think that's it. Yeah, I just have to do node copy. Dot model matrix equals node dot model matrix. I don't know if you can just copy NumPy arrays like this. Okay, I guess you can.